day, Bayaw. I'm here to give an example from Chapter 6, the gas and vapor cycle. Consider an engine operating on the ideal diesel cycle with air as the working fluid. The volume of the cylinder is 1,500 cubic centimeter at the beginning of the compression process, 80 cubic centimeter at the end, and 160 cubic centimeter after the heat addition process. Air is at 17 degrees Celsius and 100 kilopascal at the beginning of the compression process. Assuming variable specific heats, determine A. The pressure at the beginning of the heat rejection process, B. The network per cycle in kilojoules, and C. The mean effective pressure. So, the given in this problem are, our volume 1 is equal to 1,500 cubic centimeter. Our volume 2 is equal to 80 cubic centimeter. Our volume 3 is equal to 160 cubic centimeter. Our temperature 1 is equal to 17 degrees Celsius. Our pressure 1 is equal to 100 kilopascal. So, since the properties of argon at room temperature are Cp is equal to 0.5203 kilojoules per kilogram Kelvin. Our Cv is equal to 0.3122 kilojoules per kilogram Kelvin. Or our gas constant R is equal to 0.2081 kilojoules per kilogram Kelvin. And our K is equal to 1.667. So, to find this, we have the table A2. So next, our solution. Since to find the radius, so R is equal to volume 1 over volume 2. So substitute 1,500 cubic centimeter over 80 cubic centimeter. So simplify, our radius is equal to 18.75. So next, our RC is equal to volume 3 over volume 2. So substitute 160 cubic centimeter over 80 cubic centimeter. So our RC is equal to 2. Next. So first, we need to find the process at state 1 to 2, isentropic compression. So to find the temperature at state 2, temperature 2 is equal to temperature 1 times volume 1 over volume 2 raised to K minus 1. Or, substitute, so our T2 is equal to, since our temperature is 17, so we need this to convert into Kelvin. So 17 plus 273, 73. So, times 1,500 cubic centimeter over 80 cubic centimeter raised to 1.667 minus 1. So, simplify. Our temperature 2 is equal to 2048.75 Kelvin. So, next, at the process at state 2 to 3, which is our pressure is constant heat addition. Since P3 times V3 over T3 is equal to P2 times V2 over T2, or since our pressure is constant, so our T3 is equal to T2 times V3 over V2. So, substitute, our T3 is equal to 2048.75 Kelvin, which is our T2, times 160 cubic centimeter over 80 cubic centimeter. So, simplify, our T3 is equal to 4097.5 Kelvin. So, next, at process at state 3 to 4, which is the isentropic expansion. So, our T4 is equal to T3 times V3 over V4 raised to K minus 1, or equals to T3 times 2 times V2 over V4 raised to K minus 1. So, or T4 is equal to T3 times 2 over R raised to K minus 1. So, substitute, our T4 is is equal to 4097.5 Kelvin times 2 over 18.75, which is our R, raised to 1.667 minus 1. So our T4 is equal to 920.79 Kelvin. Next, at process state 4 to 1, so our V is constant heat rejection. So P4 times V4 over T4 is equal to P1 times V1 over T1. Since our volume is constant, so P4 is equal to P1 times T4 over T1. So substitute, our P4 is equal to 100 kPa times 920.79 Kelvin over 17 plus 273 Kelvin. So our P4 is equal to 317.51 kPa, which is our heat rejection. So V. So to find the mass, so we have this formula. Mass is equal to P1 times V1 over RT1. So substitute, our mass is equal to 100 kPa or 100 kilopascal times the volume of 0.0015 cubic meter all over 0.2081 kilojoules per kilogram Kelvin, which is the gas constant, times 17, which is the temperature, and plus 273, so to convert into Kelvin, so 17 plus 273 Kelvin. So simplify, our mass is equal to 2.486 times 10 raised to negative 3. So, to find the Qin, so the formula is Qin is equal to mass times the height at 3 or H3 minus H2 or equals to MCP times T3 minus T2. So, substitute, our Qin is equal to 2.486 times 10 raised to 3 raised to negative 3, which is the mass, times 0.5203 kilojoules per kilogram Kelvin times 4097.5 Kelvin, which is the temperature T3, minus 2048.75 Kelvin, which is the temperature at T2. So simplify, our Qin is equal to 2.65 kilojoules. The next, to find the Q out, so equals to mass times the internal energy U4 minus internal energy U1 is equal to MCB times T4 minus T1. So, substitute, Q out is equal to 2.486 times 10 raised to negative 3 times 0.3122 kilojoules per kilogram Kelvin times, which is, this is the CV, times 120.79 Kelvin minus 290 Kelvin. So, our Q out is equal to 0.490 kilojoules. So to find the network, so W net is equal to Q in minus Q out. So substitute, our W net is equal to 2.65 kilojoules, which is the Q in, minus 0.490 kilojoule, which is the Q out. So our W net is equal to 2.16 kilojoules. So next, so to find the map, so map is equal to W net over V1 minus V2, or W net over V1 times 1 minus 1 over R. So substitute, map is equal to 2.16 kilojoules over 0.015 cubic meter times 1 minus 1 over 18.75. So simplify, our map is equal to 1521.13 kilopascal. Thank you for watching.